already getting tough because yesterday I only asked for one side of this diagram. Now I'm asking for three pieces of that diagram. All right, X, Y, and Z. Do we have to go in alphabetical order? Absolutely not. We find what we can find. Reminder, we have Hills, SAS, and I should have emphasized this more, but it's going to happen today. You also have Pythagorean theorem. And I'll let you know up there, out of X, Y, and Z, we can start by finding either one or the two of them. One we cannot find right now. All right, so out of X, Y, and Z, we can find two of them at the beginning. One of them we cannot right at the beginning. So I'm going to let you look at that diagram right now, and I'll ask somebody to start this off with one variable we could find. And if you're going to tell me the variable, you're going to have to tell me how you're going to find it. All right, so look at all three of those. Think about Hills, SAS, Pythagorean theorem, and we'll get started by finding one of the variables. One of them you cannot find right away. I'll let you know that. You cannot find one of them right away. But the other two you could. Hills, SAS, and Pythagorean theorem, everybody. Which variable do you want to start out with? All right, let's talk. Maddie, what's good here? What are you confident in? Confident in anything? All right, well, let's look at the different pieces here. Look at, Maddie, what's Y up there? What do we call Y? Altitude. So what? And out of the two devices I gave you yesterday, Maddie, what's the only one that uses altitude? SAS, right? So don't give me side angle. SAS, right? SAS. Everyone agrees? SAS. But here you go. Here's the problem, Maddie. The S's in SAS stand for what? Segment. And one of the segments is 1, which is fine, but the other one is X. So does everyone see, if I set up SAS right now, I'm going to have an X and a Y in the proportion, and we don't want to do that. But I'm not going to give up on Y right now. Maddie, what type of triangle is that? How many sides do I already know? How many sides in this right triangle do I know the length of? 2. What do we have available to us that'll find the third? Pythagorean theorem, right? Everyone all right? We're going to use Pythag to solve for Y first. All right, that's where I want to start. Let's solve for Y using Pythagorean theorem. Remember, you always have that available to you if you have enough information. So we're going to solve for Y. Here we go. A squared plus B squared equals C squared. Watch out here. There might be a trap for a few of you. Might be a trap. A and B are your legs, right? C is the hypotenuse. So I want to know, what do we need to plug in here? Come on, Rowan, here we go. What are your two legs here?
For 1 squared plus Y squared.
Okay, yep. And then you're going to keep going, hypotenuse. There you go. Everyone good on how that works? It's not always C you're solving for. Everyone see that we had 3 as my hypotenuse. It's across from the right angle. All right, keep going. Leave your answer in simplest radical form. 1 plus Y squared equals 9. Move that 1 over. Y squared equals 8. And when you have simplest form, let me know what the value of Y is in simplest form when you have it, Jonathan. 2 radical 2. Good work. We can put that in the diagram now. 2 radical 2. 1 down, 2 to go. All right, what variable do we want to look at next? Because one you can find, the other you cannot still. There's one variable we can find right now in the second step, but the other one we cannot find. Alex, out of X and Z, what do we think? X, good. Yeah. What is X again? That's a what? Altitude. That's a segment. SAS. Now we can use SAS. Because remember my problem with Maddie was we'd have a Y and an X. Well, we already know what Y is. So now we can use SAS, and somebody's going to fill that in for me right now. So we're going to solve for X by using SAS. Ooh, okay, fill it in here for me, Matt. All right, let's go, Maddie. Now you're on board here. Segment. X, altitude. Altitude. Segment. Boom. There we go. Value of X when you have it. When you have it, value of X. Mia, when you have it. Use your calculator. Or do you cross multiplying? You're not adding, you're multiplying. 2 radical 2 times 2 radical 2. All right, 2 down, 1 to go. Any issues finding these? Next up, Z. Three different ways you could find Z. 3. As a class, we're going to do one of them in particular so I could show you something on your calculator. First way we could do it is we could use hills. Everyone see how we could use hills? Z's a leg. I have the hypotenuse and the segment next to it. We could use hills. Second way I could do to find Z. See the big right triangle. Use Pythagorean theorem on the big right triangle. 3 squared plus Z squared equals 9 squared. I could do it that way. So we got hills and we got Pythag on the big right triangle. Any issues before I reveal the third way, which is the way we're going to do it? And that is Pythagorean theorem not on the big triangle, but on this one. I want to do Pythag on this one only because I want to show you something in your calculators. Homework, quiz, test, you do it any way you want, but I want to do it using Pythagorean theorem on that triangle in particular. So I can show you something on the calc. All right, give me the 2 legs, A and B, on that right triangle up there. Sydney, what are my 2 legs? 2 legs make up the right angle. 2 radical 2 squared and 8 squared equals my Z squared. Okay, is everybody good? All right, we have no issues there. That's going to be 64 for 8 squared. Here's what I want to show you right now on your calculator with 2 radical 2 squared. If I go to my calculator right now and little calculations and I do 2 radical 2, square that bad boy, it's going to tell me 4, but that's not the right answer. Here's why. Everyone look at my calculator right now. My calculator. I didn't square 2 radical 2. What did I square? The calculator thinks I'm squaring radical 2. But as you see on your paper, we need to square 2 radical 2. So what do I need to do in the calculator to fix that? Parentheses, darn right. All right, so heads up. Anytime you need to square a number with a radical, we got to put that bad boy in parentheses. And watch, different answer. Whoa, whoa, relax, relax. 2, where do we go? Radical 2, get out there. Squared. A little different answer. Okay, because my calculator thought at first that it was just squaring radical 2. Nope, we got to square it all. So that's going to be an 8, and now go ahead and solve it. Simplest radical form, please. And simplest radical form for Z, when you're ready, Juliana. 6 radical 2, there we go. All right, a little tougher. Okay, you're gonna get a heavy dose of that on your assignment tonight. I want to emphasize this isn't the way to do it. Remember I said at the beginning that there were two variables you could have solved for? You could have solved for x at the beginning by doing hills and doing x plus 1 as the hypotenuse. All right, so many different ways we could have got to y, x, and z. Questions? All right, the last couple aren't tough. They just involve some heavy algebra. So let's look at 2. Let me talk to somebody first. Let me talk here. Hi, Rand. How are you?
I'm good. How are you?
Great. Thank you for asking. That was nice of you. What are X and Y up there, Rayhan? What are
Segment.
segments, right? They're segments. So right now, going through my head is SAS. But does everybody see a problem using SAS? No altitude, right? Ooh, hills has an S in it. And I have the 2 legs, but what am I going to have to plug in for the hypotenuse? X plus Y. That's a no-go. That's a no-go. So look, hills, SAS, out. All right, the only other thing I have is what? Okay, let's take a peek. Pythag going to work on that triangle. How about that right triangle? No, we're I kind of went through everything except one. What have I not done yet? I eliminated hills. I eliminated SAS. I eliminated Pythag on those 2 triangles. Isn't there another right triangle in my diagram? The big one. I can do Pythag on that one, and what will that find? That hypotenuse there, and then we can go to town. All right, so that's my first step is I need to do Pythagorean theorem on the big right triangle. Okay, got to do it on the big right triangle. And speaking of the big right triangle, what are your 2 legs on the big right triangle? Talk to me here. T, what are my 2 legs?
15 and 20.
Okay, here we go, everyone. 15 squared plus 20 squared equals your hypotenuse squared. When you have it, how long is that hypotenuse? 18. Let's try again. Rayhan, 2 for 2 for you.
25.
25. Good work. So the hypotenuse is 25. And here we go. Now I can do hills. Okay, now I can do hills. All right, who's doing hills with me here? Rowan, here you go, boss. Hypotenuse length.
25.
Oh, relax. I'll do the asking of questions. All right. Now it's your show. What leg you want?
15.
Okay, he's going. Hey, we could have went with 20 if I called on somebody else, right? That would have been fine too. He's going with 15 leg.
15.
And now, what segment do we have to find if you picked 15? The one next to it, which is X. Good. We're getting 9 out. X equals 9. Look good. All right, there's X. You ready for Y? Could I go through hills again and find Y? I could. Absolutely. I'm going to work a little less. Is there any quicker way I could get to Y without having to do hills again? We could. Definitely could do hills again. Where am I going there? Keating, how long is the hypotenuse again?
25.
Yeah, and I just found that one part of it's 9. Other part, just subtract it. Good work, guys. Good work. Whew. Buckle up for these next two. Sorry if your Algebra 1 skills are lacking for these next two. The last two problems, I think we can all agree, it was tough at the start. Right? SAS, Hills, Pythag, what the heck do I need to get myself started? This problem, not tough at all to get started. We should look at that diagram and know if this is going to be Hills, SAS, or Pythag right away. All right, it's the solving of it that's going to get us tough. All right, so let's take a look here. Oh, geez, well, that was scary. Where am I going there? Sydney, what's the 10? What? Altitude, what's the x plus 15? And the x. So you just gave me segment, altitude. What am I going to use? SAS, done. All right, that was the easy part. Let me plug in what Sydney just gave me. X plus 15, 10, 10, X. No issues. All right, the setup should be easy for us. Day 2 now. Now here comes the tough part, is to solve it. Maybe, I don't know. So we multiply, cross multiply, x times x plus 15 equals 10 times 10. You guys know the deal, hopefully, from last unit. X squared plus 15x equals 100. What did we do last unit? Nothing until equals 0. Great job. Got to equal 0. Uh-oh. Oh, boy. Oh, boy. I got faith in you. Come on, I got faith. If you want to go right to quadratic formula because you're nervous, go. Just go and don't worry about what I have to say. Find your A, B, and C and plug it in. Find 2 answers. You guys that still want to factor, I'm going to let you go work here. 2 numbers that do what? Multiply to? Negative 100. Multiply to 100, but at the same time, add to 15. Oh, 100 is such a large number. Suck it up. Here we go. 2 numbers that multiply to 100. Or again, you don't want to play this game with us? Go right to quadratic formula. Make sure you do the plus and the minus version in your calculator. Numbers that multiply to 100. Oh boy, that's a fun game. 1 and 100, no. 2 and 50, no. 10 and 10, no. Anybody who did it this way, think they got them? Confident you got them? I don't want to call them a number because you may have done quadratic formula, which is fine. Confident you got 2 numbers. Jesse, what's good? How was your factoring game last year?
It was good.
On point? A game? All right. What do you got for me? What are your 2 numbers?
20 and negative 5.
I like those. Positive 20, negative 5. Yep, they do the trick. So we get x equals negative 20 for one answer, and x equals 5. If you do quadratic formula, you should get both those too. Anybody got a problem? Well, I still got a problem. I'm not comfortable moving on to number 4. Nobody has a problem right now. Can't have a negative side length, right? If I take negative 20 and plug it in for x, that gives me a negative side length. Rejected. I can only have 5. Any issues? All right, one more tougher one now. And then you guys are on your own. Ooh. 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 All right, let's talk. Jackson, what's that 26? All right, hypotenuse. So my mind starts going hills, hills, hills. But what's the L stand for in hills, Jackson? Leg. And if you guys look at my diagram, they're blank. Right? They're blank. Out. out. There goes Hills. No shot. I don't have any legs in the diagram. Lennon, what's that 12? Altitude. So now I'm starting to think SAS. But I only have that one segment X. Or do I? I have X, right? But I know some of you are going to say, your other segment is blank, so you can't use SAS. You sure it's blank? Can you actually put a label there for me? Lennon, what was the hypotenuse again? 26, right? This piece is X. Is there anything we can write here that represents the other piece, the other segment? All right, well, how can the whole thing's 26? This is X. How can you write what this segment is going to be using the 2 there? Using the 2. Thoughts? I don't want to put anybody on the spot here. What's up, Hayden?
26 minus that.
Yeah, hey, look. If I told you that was 10, what are you going to do to find the other side? 26 minus that. If I told you it was 15, you're going to do 26 minus 15. But it's X. So yes, Hayden's correct. I go 26 minus X. Even if you threw out SAS and went to PyFag, there's no way you can do PyFag on any of the triangles. No way. So this is the only way we're going to be able to do it is using SAS. So segment, altitude, segment. And you're still not out of the woods. We got some serious algebra coming up now. You thought 100 was a big number earlier? Woo-hoo, here you go. You thought 2 numbers that multiply 100 was bad? (26x minus x squared equals $1.44). Whoa, before we do anything equal to 0, always try to keep your x squareds positive, right? Positive, because I don't know how you factor something that's got a negative x squared. So I know it's convenient to move that 144 over to the left. I know it's convenient, but you still have negative x squared, and that's not going to fly with me. So instead, I know it's not the easy. It is easy, but just not convenient. I'm going to move over the 26x by subtracting and add the x squared over. So it's positive. Try to keep your x squareds positive, kids. Now I have 0 on one side. Write it in the correct order. X squared minus 26x plus 144. You thought 100 was bad. All right, I'll let you guys do what you got to do. Quadratic formula. Or try to find 2 numbers that multiply to 144 but add to negative 26. Using whatever tricks you have in your calculator. I don't have a trick, by the way. I just guess and check. I just start guessing numbers that 144 divided by this, 144 divided by that, and see if I can get 26 out of it. I don't have the table trick that some of you guys have. I don't have a magic X school bus method. And quad formula is always good too. Just make sure you do the plus and minus version in your calculator. Any factoring champs want to reveal their numbers? Think you found them? Hayden, think you found them?
X minus 18, X minus 8.
Negative 18 and negative 8. Yep, both have to be negative. Yep. They'll give you negative 26 and positive 144. Good work. All right, so ready? X equals 18 and X equals 8. And even at the end of the problem, you got to be on your toes. Everyone plug in 8. Is that okay for a side length? If I plug in 8, will it give me a negative side length in your diagram? No? So I can keep it. Now plug in 18. Is 18 going to cause a problem at all? No. Both answers result in positive side lengths. So unlike the last one, I don't reject anything here. Okay, so even be on your toes at the end of the problem. All right, you got some work to do in your textbook. Let's get moving. Hill, Sass, or